everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see Module 1, Part 2, Question Bank Discussion. Okay, so lecture topic will be same like Module 1, Question, that Part 2 video or next question we can see. So let's see, the first question is, a cantilever beam made of cold drawn steel, okay, 40C8, that this steel name is given, whose, that's why here it's there, S ultimate is 600550 Newton per mm square, that is given, okay, and SYT is equals to 38055 Newton per mm square. Either they will give directly this value or they will provide you the chart from where there you can find SUT and SYT value, because just see that name is given. Once the name is given from that chart, or you have to take that value, or else if suppose they won't provide the chart, then they will give you directly in the question itself the value, just like here, because here I cannot show the chart, that's why just I mention this one. With this value directly you can find. Okay, so that cantilever beam is showing here. So load is applied at the free end, this end is fixed. Okay, the force P acting at the free end varies from minus 50 Newton to 1 plus. So here that load is acting to minus 50 to 150 Newton. Means what again? This is W minimum, this is W maximum. The expected reliability is 90% and the factor of safety is 2. The factor of safety is given, reliability is 90% given. The notch sensitivity factor at the fillet is, so just see here, this one, at the fillet, it's not throughout, it's a cross section. So here you can see, if you will see this part, this should be a straight. But this is not the straight, this is the curve. Right? So there, that is only the notch. For that, notch factor at the fillet is 0.9. Right? So here one new word came from the previous question. What? That is notch factor. What we did in first video, that was notch factor was not there. Then whole that uniform cross section was there. But here, that up to this some different cross section is there. That is 1.52 D, and here the cross section is different. So that's why here the notch factor is given. Then determine the diameter D of the beam at the fillet cross section using Garber's curve. That is here. Just see, as already mentioned, that if it's a for non-linear one, what we are using the Garber's curve. For linear, Suderberg and Goodman. Right. So this is the third type of Garber's curve. Everything will be same. Only the second term will have the square root. So what we have to find? This diameter. Okay, this D we have to find. So let's see. What is given? S ultimate plus S ultimate is given 600 Newton per mm square. SYT is given as 380 Newton per mm square. It's not Newton mm2, it's Newton per mm square. Okay, R, that reliability is given as 90%, that we can say at 0.9. Q, that notch factor is denoted by Q, that is given as 0.9. Factor of safety is given as 2. P is from where to where? Minus 50 to 150. Okay, we know that S dash E is with 0.5 SUT. Okay, now this is why 0.5 UT. Right, S dash is, as I already told you, that is given in the, that according to the material, that will be here. So SE is 0.5 SUT. So 0.5 into SUT is 600. So that is 300. Right? Now for cold stream drawn and SUT 600 Newton per mm square, Ka equals to 0.77. That is from that book, that table you will get there, or else that value directly will be given in the question itself. Right? So now 0.77, that Ka value is there. Assuming 7.5 is the diameter is greater than 7.5 and smaller than 50 mm. Okay, that is there. That time Kb will be what? 0.85. Again, this will be from that chart on your table. For 90% reliability, again this will be from the table, that is Kc equals to 0.897. So now we have what? Ka, Kb, Kc. Right? Since R by D is what? 0.5, just half of that one. So D by D is given as 1.5. Kt as, okay, Kt as 1.44. So now these data, from here, right, from here, all the data you will get from the chart. Okay, so you will get the chart, and from there you can find these data in the chart. Particular once you will have go for the 600 Newton mm square as already did, right. From there you can find these data. So now we have all the data. Now the thing what is required to find, right? So just see here. Okay, so determine the diameter. So again we have to find d. So d is equals to what? Okay. So now first concentration factor that is given. Q is given. Kt is from the table. So now this is the factor. This is the formula for that concentration factor in terms of notch. Okay, in terms of notch concentration, how to find concentration factor when notch is given. So the formula is Kf equals to 1 plus Q, that is notch factor, into Kt plus 1. So now let's see Kf. Okay, 1 plus notch is how much? 0.9 is given. Okay, Kt from the table we got 1.44 plus, sorry, it should be plus, yeah. Sorry, here it should be minus. That minus should be there. Okay, minus. So after solving this one, Kf is equals to 1.3967. Okay, or just see here. So after this, what we'll get? 1 plus 0.9, 1.44 minus 1, so 0.44. So this term will get multiplied. So 1 plus 0.9 into 0.44, if you will multiply, you will get 0.3967. So after adding 1.3967, that is here. So now we have Kf. Now Kd is 1 by Kf. So 1 by 1.396, that will give you 0.716. Now what is there? That Se we have to find. For that, S dash E already we found. Now Se will be equals to what? So just see for formula for Se, that endurance, that is Ka into Kb into Kc into Kd, okay, into Kf into S dash E. Now everything we have, Ka also we have, that is 0.77, okay, into Kb 0.85, into Kc 0.897, into Kd Ka, Kb, Kc, Kd is 0.716. Okay, that Kd 0.716. Okay, and then Kf 1.396, okay, that is missing here, that 1.3967. And then Se how much we got? Just here, Se dash, that is 300. Just put the value 300. Multiply all, what you will get? Se equals to 1 to 6, that 126.11. So now we have Se. Now construction of Gerber diagram as the fillet cross section, that MB into max, M is given that 150 into M max is given 100, right? So that will give you 150, that 15,000 Newton mm. So MB for mean, that is minus 50, and that is given that, okay, minus 50 into 100, so that will give you minus 5,000 Newton per mm. Okay, now we will apply this one. So MB mean means what? Mean we have to find, right? So mean again, we can say that maximum plus minimum by 2. So half of maximum, okay, plus minimum by 2 will give you MBM, right? Next, so after putting the value, what is the maximum? 15,000, minimum 5,000 divided by 2. So finally 15,000 minus 5,000 by 2, 10,000 divided by 2, 5,000 Newton per mm. That we got M. Now next step, what? Sigma B we found. Now here we are finding the moment, right, in that time. So now A or MBV we have to find. So MBV equals to what? MB max minus mean. This time for variable or amplitude, right, or alternating, MB minus MB max minus MB mean divided by 2. So 1 by 2, 15,000 plus 5,000. Why 5,000? Because of that minus is coming, right? Minus of 5,000. So, or you can just write here, that is equals to MB max. So 15,000 minus of minus 5,000 divided by 2. So this becomes minus and minus plus. So 15,000 plus 5,000 divided by 2. So this becomes 20,000. 20,000 divided by 2 gives 10,000. So that's it, 10,000 Newton meter. Now we have this two. Okay. Now for finding the angle, that theta, tan theta is MB, that amplitude, by this one. So after putting that value, how much we will get? Okay, so tan theta equals to what? MBA. MBA is almost 10,000. MBA by MBN. So actually here this should be MBN 10,000 by how much? 5,000. 1 by 2. Okay. Wait, here some mistake is there. MBN, this is 10,000. Sorry, 15,000 divided by 1,000. So that is tan theta. So theta will be equals to tan inverse of how much? That 50. Right. So after that you will get theta equals to 63, or just after simplifying you will get the theta value as 63.43, that angle. Now the coordinates of x, that SA, SM, are determined by the following two equations. So this is the Garber's equation, SA by SE plus SM by S ultimate whole square equals to, so this here, this with this term only the square is there, equals to 1. So this is the Garber's equation. Now just substitute the value, everything you have, SA we have, SE, SM. So SA and SM we found, SE and SUT was given. Just substitute. Right. So for first case, okay, SA by 126.11 plus SM by 600 square equals to 1. This is first. Second, equation of a straight line, OX. So now let's see here in this case for equation of this one. Okay, SA by SM. So let's see here. SA. So this is what? SA by SM. So here, this is opposite by adjacent. Right? So opposite by adjacent means it's a tan theta. So tan theta will be equals to what? Right? SA by SM. So SA by SM is tan theta. Right? So after putting that one, what we will get? S tan theta equals to SA by SM. What we got? SA as 10,000 divided by SM as 5,000. So 2. So tan theta is equals to 2. Okay. Now substituting the equation B, this one, in equation 1, we will get after just SA by SM as 2. So here SA by SM, or SA, from here what we can write, that SA equals to 2SM. Right. So we can replace one variable. Okay. So or SM as SA by 2. So now just here. So SA as 2 SM. Okay. So here now just replacing in this equation. So see what we have, that SA by 126.11 plus SM. Now what is SM from here? SA by 2. So SA by 2, that is 2 into 600, this whole square. Okay, that is equals to 1. Now just see why we did, because now only one variable is there, that SA. Right. So now we can find SA. If in this equation SA and SM both are variables, so for that only we found that equation SA by SM, another equation, because 2 unknowns, so these two equations is required. So another equation is what? SA by SM equals to 2, or you can say SM equals to SA by 2. So now replace SM here. You can replace SA also, because SA is equals to 2sm. So you can put here as 2sm and then you can solve for sm. Okay, once you will have the sm, divide just for finding SA, 2 into sm will give you the SA. So either way you can do that. It's not necessary that you have to do or you have to replace sm only. Okay, so now after substituting here SA by 126.11 plus SA by 2 into 600 whole square is equals to 1. So this is the equation or equation number C. Now this equation you have to solve. So how you will solve? So just see, I'm writing that SA by 126.11 plus this will be what? That we can write SA whole square by this one. I'm just writing this 4, 2 square is 4 into 600 square. That is equals to 1. Now take the LCM and then expand. So after taking LCM, multiply and just expand, that will be of the quadratic type. So once you have the quadratic equation, that quadratic equation will be this one. Just you have to expand and simplify this one. Or let me solve previous step, then later you can do. So now this will be what? SA by 126.11 plus SA square divided by 600. That is 4 into 36,000. That is equals to 1. So 4 into 3,60,000 into 1.126.11 will be the LCM. Right. So after that, what you have to do? Just take this side, or this you can say there directly this as 2 square. So 4 into 4. The 2 into 600, that 1200 square, that is here. Like that also you can write. So after simplifying, you will get here SA square as 11418.6 SA minus 1200 whole square. So now this is a form of what? Quadratic equation. So once you have the quadratic equation, 2 value you will get. So what we are finding SA, so definitely that SA will be what? Positive value. So after solving, whatever the value will come in that, we have to take the positive value, and that is 124.75. So hence now we have SA equals to 124.75. What is SA? SA is 2sm. So sm is equals to what? SA by 2. So that we can write that as 124.75 by 2 will be the sm. Okay, that is around 62.36 or 37. Let's see here. The diameter of cantilever beam is sigma A equals to SA by Fs, right? So here, okay, that 32 MB by pi d cube, okay, is equals to SA by Fs. These two equations are there, right? Just equate these two. So this is a moment equation with the moment of inertia pi d cube 32 by, so m by I equals to SA by Fs, the moment, that one, bending moment equation, right? So I is here what? For this one, it's a pi dq by 32. So after putting that mb by pi dq 32 SA. So now mba we found, right? So here, now just from here what we can say? SA by Fs, that is equals to sigma A, right? So here is that one. So pi d 32 into 10,000 that we got, pi dq equals to 124.75 by 2. That factor of safety is given as 2 because sigma A is this one, factor of safety 2. Now here just cross multiply. So after that what you will get? 32, just multiplying 32 and 40. Okay, by pi dq, okay, equals to 124.75 by 2, right? So this you can multiply and process. So 32 into 2, 64, okay, by 124.75 into 5, right? This coming this side, and that is equals to dq. So solve, simplify this one, and then take cube root of this value. You will get, so d will be equals to what? Cube root of 640000 divided by 124.75 into 5. So this value will give you the value of d. So after solving this one, what you will get the value of d as 11.78 mm. Okay, so this will be the diameter of this one. So let's see quickly once again. Okay, because here some new things are there, so just see quickly. That is given as steel 40840C8, means that a particular steel is there that have some specific value. That value you can get it from the chart, or that will be given in the question. So here that S ultimate given that 600,550 Newton per mm square, and SYT given as 380,550 Newton per mm square. The force P is acting here. That P value is given, it's a variable type, minus 52 plus 150 up to, right? So minus 50 will be the minimum and plus 150 will be the maximum. Okay. The expected reliability that is given, that R is given as 0.9. Determine the diameter D. That D we have to determine. Okay. And the fillet cross section using Garber's curve. So that Garber's curve is that equation we have to find, because it's not linear here because of this notch. Only it's not linear, that is of the curve types, that is given as 0.2 D. The diameter of this curve is 0.2 D. But what we have to find, this diameter we have to find from here to here. What is that? Right? So let's see, again something is required here. So this is given SUT. Okay. SYT is given, reliability is given as 90%, Q is given as 0.9, notch, factor of safety given as 2, P is given minus 52 plus 150. We know that SE dash equals to 0.5 S ultimate, that half of that one, so 0.5 into 600, that is 300. Okay, for cold steel drawn, SUT is 600 Newton per mm square. Okay, that is there. Okay, so KA SUT 600 Newton per mm square, that time Ka will be 0.77, that is from the chart. Assuming 7.5, that is diameter is less than, greater than 7.5 and less than 50 mm, just assuming. For that, because that for that Kb value we have to take. So in that range Kb value is coming 0.85. So now Ka we have, Kb we have. For reliability, 90% reliability, just see why that reliability is given. For that, to find the Kc value, for 90% reliability, Kc is 0.897. Since R by D, that ratio is 0.5, so and D by D is given as that 1.5, Kt will be equals to what? 1.44. Now this Kt is required to find the what? That Kf in case of notch sensitivity. Let's see, concentration factor Kf as 1 plus Q into Kt minus 1. So here that is minus 1. Substitute the value of Q and Kt value in the above equation, we will get the value, right? Let's see, Kt what we got. That as 1.44, right? Just substitute Kf equals to 1 plus 0.9 into 1.44 minus 1. After simplifying, Kf is this one, right? Now Kd is 1 by Kf, right? So 1 by 1.3996, you will get that Kd equals to this one. Now from here Se we will find. Se will be equals to Ka, Kb, Kc, Kd, Kf. All the factors whatever affecting that one, all the factors you have to multiply and then Se dash. So after multiplying all the factor, what do you get? Se as 126.11. Okay. Now, so instead of this time we are finding in terms of stress, we are finding in terms of moment. So moment, okay, that maximum will be what? 150 into 100, whatever the distance is there, right, of this one, right? So force into distance is the moment, right? So force, that maximum force is 150 into distance 15,000. MB, minimum force into 1000. So MB mean that is minus 5,000 Newton meter. Okay. So now we have MB max, MB mean. So that in terms of that only we will substitute in the Garber's equation. Now what we require? MB mean and MB alternate, or MB V you can say. So MB mean is what? Sum of all maximum and minimum by 2. So here sum of maximum and minimum. So here what is MB? MB is 15,000 plus and MB mean is minus 5,000 divided by 2. So 15,000 minus 5000 divided by 2. This will 10,000 divided by 2, that is 5,000 Newton mm. Right? So MB. Similarly, MB mean. Similarly, MBA, what? MB max plus. So this time what happened? Minus of minus get added, and then MBA will be 10,000 Newton. Right? So that from here now apply the Suderberg equation. Okay, so in that SM, SA. So now in terms of SA we have to find, because we found SE, not SA. Right? We found here SE to find MB. Okay. Now, so just put the value. So SA by this value, right? SE value plus SA by SE plus SM by the 600 whole square. Now, another equation from this triangle, right? In triangle OXSM. So let's see here. Tan theta is equals to what? Okay. This one. That SA by SM. Opposite by adjacent. So tan theta is SA by SM. So SA by SM is equals to tan theta. So after this, what we got? The tan theta is 2. So from here we can say SA equals to 2SM. Or just replace SM as SA by 2. So here in this case I replaced SM. You can replace SA also. So SM by 2. So after substituting here, this is the value of this one. Now just expand this one, solve, that becomes a quadratic equation. That quadratic equation will be what? This one, right? After solving this quadratic equation, you will get the value of SA. Now you have SA, right? So after SA, what we have to find? Right? The diameter of the cantilever. So sigma A, one formula is SA by Fs, and another formula in terms of bending equation, that M by I. So I is here pi dq by 32, M by I. So I, right, equals to SA by Fs, or sigma A simply. So M by I equals to sigma A. Okay. So this is I is pi dq by 32. That is here, right? So now these two equations are same from here. So 32 MB by pi dq equals to SA by Fs. Now put the value. 32 into MB is 10,000 divided by pi dq, and SA we found 124.75 divided by 2. After cross multiply, and whatever the value will come, take the cube root of that one, you will get the value of D, that is 11.78 mm. Okay. So again, you can refer the Maxon book for this question also, right? So if you have any doubt, any question, you can just comment, or you can contact me regarding your doubts or any step if you will not understand how that value is there, like many things we use from the chat, right? So that you can just contact me. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.